Hello viewers, in today's class we are going to solve one important definite integral, right? So here we have to evaluate the value of the integral 1 over x times x raised to 5 plus 3, and the limits are from 1 to 2, right? So let us start. So here let us call this integral as I. Now in this integral uh, we will use two methods, right? The first one is the method of substitution, and the second one is the method of partial fractions, right? So let us first write this integral as 1 to 2, and let us write x raised to 4 in the numerator, and in the denominator we can write x raised to 5, and this is x raised to 5 plus 3. Now what we have done here, we have multiplied the numerator and denominator by x raised to 4. Why? Because the derivative of x raised to 5 is 5 times x raised to 4, right? Now if I write 1 over 5 here, and if I multiply it by 5, the numerator, then we see that the derivative of x raised to 5 plus 3 is in the numerator, right? So this is how we do this manipulation in this function, right? So now once we have obtained the derivative in the numerator, we can substitute t is equal to, say, x raised to 5 plus 3, right? So therefore dt is equal to 5x4 dx, right? So now here for 5x4 dx we can write dt. Clear? Okay, now let us change the limits accordingly. So here when t is equal to here we have x. So when x is equal to 1, the value of t is 1 raised to 5 plus 3, that is 1 plus 3, that is 4, right? And when x is equal to 2, then we have t is equal to 2 raised to 5 plus 3, that is 32 plus 3, 35, right? Okay, now this integral can be written as 1 over 5, and integral from 4 to 35, and for 5x4 dx we can write dt, and in the denominator we have for x raised to 5 we can write t minus 3, right? Okay, so here we have t minus 3, and for x raised to 5 plus 3 we have t, right? So now the integrand is reduced to 1 over t times t minus 3, right? Now this is a combination of linear factors, so we can now use the method of partial fractions. So since in the denominator we have two linear factors, so this rational function can be written as a over t plus b over t minus 3, right? So now this is equal to taking LCM. So here we have a times t minus 3 plus bt divided by t times t minus 3, right? So now comparing both sides, we get 1 is equal to a times t minus 3 plus bt, right? Now from this expression we can find out the values of a and b. Now to get the value of a, we can write t is equal to 0. So when t is equal to 0, we get 1 is equal to a times 0 minus 3 plus b times 0. So we have 1 is equal to minus 3a. So a is equal to minus 1 over 3. And when t is equal to say 3, right? Because in this case this term will get eliminated. So here we have 1 is equal to a times 3 minus 3 is 0, and this is b times 3, so 1 is equal to 3b, and we get b is equal to 1 over 3, right? So now this expression is equal to 1 over t times t minus 3 is equal to a is minus 1 over 3, we have t, then we have 1 over 3 for b, and this is t minus 3, right? Okay, so now this integral becomes 1 over 5, and here we have the limits from 4 to 35, and the integrand 1 over t times t minus 3 is minus 1 over 3 t plus 1 over t minus 3 dt, right? Here we have 1 over 3, right? Now we can take 1 over 3 common or outside the integral sign, so we have 1 over 15 here, and the limits are from 4 to 35, and we have minus 1 over t plus 1 over t minus 3, right? So now viewers, we know that the integral of 1 over t dt is log of t, and the integral of 1 over t minus some number say a dt is log of t minus a, right? So here we have 1 over 15, and the integral of 1 over t is minus log t, and here we have a log of t minus 3, right? And the limits are from 4 to 35. Now by the property of log, we can write this as log of t minus 3 over t, and the limits are from 4 to 35, right? So here we have used log of m minus log of n is equal to log m over n, right? Now we can simply substitute the limits here, and we'll take the difference. So now this is 1 over 15, and here we have log, when we take 35, this is 35 minus 3, 32 over 35, and then we have minus, and we'll take 4, so 4 minus 3 is 1, and divided by 4, right? And here again we'll make use of this property, right? So we can now rewrite this expression as 1 over 15 log 32 over 35 divided by 1 over 4, right? Which can be written as 1 over 15 log 32 over 35 times 4 over 1, right? We'll take this 4 to the numerator. So this is 1 over 15 log, and 32 times 4 is 4 to the 8, 4 3 is 12, 128 over 35, right? So viewers, the value of this integral, this definite integral, is 1 over 15 log 128 over 35, right? So this is how we solve this definite integral.